here are the objectives of today's CEU presentation. First, we'll discuss the problems that healthcare facilities face related to hospital-acquired infections. You'll hear me refer to HAIs, which really is just short for hospital-acquired infections. We'll then review the technologies that have shown to have had a dramatic impact on reducing hospital-acquired infections, or HAIs. And these technologies are UV disinfection, copper coating on high-touch surfaces, and ozone disinfection and hand hygiene sinks. So really by the end of the presentation, you'll have a deeper understanding of the benefits of ozonated water related to hand hygiene. And lastly, we will discuss how ozonated water technologies specifically benefit hospital cleanliness and improve patient outcomes. But before we do that, I would like to just kick off looking at some of the basics, having a look at some of the stats regarding healthcare or hospital-acquired infections. So these statistics really are alarming if we start putting the numbers to it. Approximately every 157 seconds, a patient is infected with an HAI. Every 52 minutes, a patient dies from an HAI. So that really puts things into perspective. If we look at this presentation, I did mention that the CEU will be about 50 minutes. Sadly, by the time we conclude this presentation, we will have lost somebody from a hospital-acquired infections. So if you're a patient in a hospital, you have a 1 in 20 chance of acquiring an HAI. And if you are unfortunate enough to acquire an infection, you have a 1 in 20 chance of it being fatal. So it really becomes quite alarming and sobering if we start having a look at some of these numbers related to HAIs. We look at the domino effects of HAIs. There are approximately 1.7 million hospital-acquired infections in the US each year, and sadly, almost 100,000 of these are fatal. The truth around HAIs, in addition to the loss of life, they are also very expensive. The estimated average direct cost for HAI treatment is roughly $30,000 per case. And according to a recent University Health Network study, C. diff cases cost approximately $38,000 to treat. I will be going into more detail on C. diff as we progress throughout the presentation. But looking at those numbers, it certainly is not small amounts of money when we are having to deal with HAIs. So the direct treatment cost for hospital-acquired infections is estimated at $106 billion. The total direct, indirect, and non-medical social costs of HAIs are estimated at around $96 billion to $147 billion annually. So this includes the loss of work, legal costs, and any other patient factors. So the total cost to the healthcare system, to families, and to the economy is even higher. So really, if we have a look at this domino effect of HAIs, it really has a very significant impact on the healthcare system and on people's lives. So infected patients remain in hospital significantly longer before being discharged. Approximately 10% of acute care beds in urban hospitals are occupied by patients who have had an increased length of stay due to an HAI. 10% of occupancy is not a small number. So when patients remain in hospital longer due to an HAI, they take up valuable bed space, and very much top of mind having to deal with the COVID-19 pandemic. Space in hospitals and overcrowding is a very, very significant impact. HAIs have not disappeared throughout the COVID-19 pandemic, so really this just adds to the domino effect of the overcrowding crisis. So ER wait times are increased because the ER is stacked full of patients waiting for a bed to free up. The HAI crisis contributes to the overcrowding crisis, as I mentioned, which really contributes to the emergency department waiting time crisis as well. So I'm not sure how many of you know about these statistics, but HAIs are among the leading causes of death in North America. In fact, when we look at both Canada and the US per capita, HAIs are estimated to be the third leading cause of death. So again, very alarming statistics. And again, pre-COVID-19, we would have seen some of these causes of death move around somewhat with the introduction of COVID-19. Nevertheless, HAIs are still there in the top 5 causes of death in North America. So I'd like to now move on to look at the techniques that hospitals and healthcare facilities use to prevent the spread of HAIs. So again, this presentation was created long before COVID-19. We can appreciate that hospitals have improved their room cleaning protocols in the last couple months or year now. But traditionally, rooms are decluttered, cleaned, and then disinfected to be set up for the next patient in terms of traditional cleaning. So this process typically is done with cloths and harsh chemicals. I'm sure we have all seen this at some point in a healthcare setting. So manual daily cleaning takes approximately 15 minutes to complete. And this involves surfaces that are spot cleaned since patients are still occupying the room. We have a look at a room turnover or a terminal clean. This is performed after a patient has left the hospital and prior to a new patient being admitted to that room. The third form of traditional cleaning is known as an isolation clean, and this is a deep cleaning performed after a patient who has been in isolation or who has had an infection has left that room. An alarming point, if we have a look at traditional cleaning, at best, less than 50% of the surfaces are properly disinfected using traditional cleaning methodologies. And this really doesn't matter if we are doing a daily or a turnover or a post-isolation clean, we only see a 50% efficacy of traditional cleaning methods. So I'd like to explore some technologies that can help prevent these healthcare-acquired infections. You will see that there's a theme that emerges throughout the presentation, that we refer to them as emerging technologies, and not because they're new necessarily, but because their use in the healthcare setting is becoming more and more prevalent. As I indicated earlier in the presentation, these technologies are ultraviolet disinfection, copper touch surfaces, and ozone disinfection and hand hygiene sinks. But before I go into the technologies in more detail, I would like to just put a bit of a spotlight on the bacteria that hospitals are dealing with daily and the use of these 3 technologies in combating these bacteria. I mentioned C. diff earlier on in the presentation. This really is one of the most frequent infections to occur in hospitals. C. diff exists as a vegetative state inside the human body, and when outside the human body, it can exist as a spore, which can easily be airborne and spread to surfaces. It really spreads very, very rapidly. The challenge that we have with C. diff is that alcohol-based hand sanitizers cannot kill C. diff spores. So again, if we think about traditional cleaning methodology with alcohol-based cleaners and cloths, it becomes fairly limiting or very limiting when hospitals are trying to combat C. diff. MRSA is another bacteria. In fact, it's a staph bacteria that has become resistant to many antibiotics. So most MRSA infections occur in people who have been in hospitals or other healthcare settings, such as nursing homes and dialysis centers. So really some aggressive bacteria that hospitals were dealing with pre-COVID and continue to deal with in light of everything that they have to take on with the pandemic. So looking at UV disinfection. As I mentioned, these are emerging technologies, and UV disinfection certainly is not new. Its antimicrobial properties were discovered about 200 years ago, and it's been used for air, water, and surface disinfection since the late 1800s. So what studies have shown is that UV disinfection works. It has shown to have a dramatic impact in reducing HAIs. So UV light will disinfect all surfaces and is extremely effective when used in conjunction with traditional cleaning or in tandem with traditional cleaning. So what studies have shown is that rooms disinfected with UV have shown reductions of HAIs by as much as a half. So that really is significant if we start looking at some of the limitations of traditional cleaning. So this slide illustrates the burden on cleaning staff during outbreaks. And we can see here, it is pretty evident if you have a look at the Twin Peaks towards the right of the slide. And you can see over here that cleaning times are tripled with an outbreak. If you think about terminal cleaning, traditional cleaning times are tripled with any outbreak. So what this graph shows is the overtime hours at a hospital for terminal cleans. And you can see that with an outbreak of a norovirus, how that sky number rockets towards the right. Very interesting point about this illustration is that after the introduction or addition of UVC cleaning, the required cleaning has dropped significantly, and you can see how that graph or the overtime hours tapers off there to the right of the slide. So it really goes without saying that with less HAIs, there are less terminal cleanings required. And from a hospital administration point of view, the potential payback for such a system is evident. So here is a study done on C. diff and how difficult it is to remove from hospital rooms. Before a manual cleaning, patient rooms were tested for the presence of C. diff in this particular study. And 7 of 21 rooms tested positive. After a manual cleaning was done, 5 of the 21 rooms still tested positive for C. diff. And after the introduction of UVC disinfection, 0 of the 21 rooms tested positive for C. diff. So a very good study and illustration on how effective UVC is in combating C. diff. So I'd like to move on to copper touch surfaces and how they are used in healthcare environments. Similar to UV disinfection, copper has been known to be antimicrobial for a very long time. Certainly a lot longer than any of us on the CU presentation. It dates all the way back to the ancient Egyptians, Greeks, and Romans. Copper is EPA registered as a pesticide and can reduce CFUs by 99.9% in less than 2 hours. So here is an illustration of real-world examples of the reduction of surface pathogens by changing high-touch surfaces to copper. So this is an ICU room at the Memorial Sloan Kettering Cancer Center in New York. And you can see on the slide that they have changed the bed rails, food service trays, the IV stands, all to copper-coated surfaces. And what's remarkable about this particular case is that they were able to reduce pathogens by as much as 97%. So if we reflect back to traditional cleaning, again, a very effective technology in reducing pathogens. So what the slide also illustrates is that without doing construction, taking the room out of service or use, not having the healthcare system have a loss of revenue for however long it would take to remodel, there is a very clear and quick return on investment here. So here is another example, and this is at the Ralph H. Johnson VA Medical Center in South Carolina. And we can see in this case as well that they have converted a lot of the high traffic touch surfaces to copper. In this particular case, they were able to reduce pathogens by as much as 58%. So really, copper surfaces are a passive way to reduce the bacterial load on high touch surfaces. And again, similar to UV disinfection, when used in tandem with traditional cleaning, it's effective in lowering HAI occurrences. So we often get asked the question by engineers and architects and healthcare administrators, what is the return on investment? What is the payback? Before we have a look at that, as I mentioned earlier, the fact is that HAIs cost money. The return on investment for converting to copper touch surfaces really is undeniable if we have a look at the figures. We also need to bear in mind that not all HAIs cost the same amount of money. These vary. On the low end, an HAI can cost $29,000 per infection. On the high end, it can range as much as $43,000 per infection. The cost of retrofitting high-touch surfaces with copper in patient rooms is approximately $52,000. So payback can range from as little as 29.2 days to 43.3 days. So again, really undeniable as far as a quick and effective return on investment. And so what this slide illustrates is just a few copper touch surface products that are readily available in the market today. I have personally seen these in healthcare settings. I'm sure some of you may have seen these if you have been in a hospital or various other healthcare settings, but these range from a broad range of products, from stethoscopes, kidney trays, IV towers, block aligners, and handles. The list really goes on. So moving away briefly from a healthcare related example, here's a real life non-healthcare example of a very high traffic area. I'm sure you all recognize where this is. This is the New York Grand Central Station. It opened its doors in 1913. So some of these fixtures can be as old as 107, 108 years old. And it really is a high traffic area. 750,000 people passed through it every single day, and that was obviously pre-COVID. So a very interesting study that I would like to share with you is that swabs were taken on a few of these high-touch surfaces at the Grand Central Station. You can clearly see the difference in CFU between copper and other touch surfaces. What's also very clear is that lacquered wood definitely doesn't kill bacteria. So we can see they're very highly effective on these old copper touch surfaces. So what's interesting about the example is that a renovation was completed approximately 27 years ago at the Grand Central Station. What we do not know is whether these high touch surfaces, these copper handles, were replaced during that renovation. We've heard about the copper roof structure. We've heard about some of the statues that were renovated, but we do not know if these high touch surface handles were renovated. But irrespective whether they are 27 or 108 years old, they certainly are still very effective against combating or CFU. So what I would like to move on to now is ozone disinfection and hand hygiene sinks. So you may see a reoccurring theme here that these technologies are not new, as I had mentioned. So ozone has been used for water treatment for centuries. It really goes back to the early 1800s. So what we know about ozone is that it's an extremely effective oxidizer. It's more than twice as effective than bleach for killing bacteria. It kills bacteria significantly quicker. It's non-toxic, and it's eco-friendly as well. It's also safe. It's registered by the EPA as a food-grade sanitizer. Some of you may be asking the question why we are comparing ozone to bleach in this particular example. The reason for that is that bleach really is what's being used by healthcare systems to clean sinks and to kill bacteria. What we also know is that ozonated water is extremely effective at killing most forms of bacteria, such as Legionella, E. coli, and more. Obviously, Legionella is a very topical point nowadays, specifically with a lot of facilities being closed down and reopening. Legionella is a very topical point that people and facilities are busy addressing right now. So the issue that we have is that a lot of these bacteria we cannot see, but people know that they have been infected with them because they become critically ill. Many people will recover, but unfortunately some people will succumb to a lot of these forms of bacteria. So having a look at, we spoke about the non-visible bacteria. There are also visible bacteria. I'm sure we have all seen different forms of visible bacteria in the form of mold, mildew, and other mildew-forming organisms. So this is an interesting study that I would like to share, and this is quite a graphical example of the inside of a hospital ice machine. And this is only 3 months after it was cleaned, and we can clearly see that it is full of mold. This particular hospital ice machine used regular pipe or tapped water. And really what this illustrates is what we may find in various other hospital ice machines or in hotels, cafeterias, gas stations, and many, many other places. So on this particular example, a news station had a report on ice machines in restaurants, and what this demonstrated was bacteria and fungus in ice in such high numbers that consumers could and were becoming very, very ill from ingesting it. So what we also know is that the freezing process does not eliminate the bacteria from the water. So ice machines do not necessarily get cleaned as much as what they should. And furthermore, health inspectors at best really are only going to check for visible contamination. That's really if they check the ice machine at all. So that really kind of puts the question out there, what about the mold and bacteria that we cannot see? And here is a very, very good example. And this particular ice machine used ozonated water. And we can see that this particular ice machine, after a good couple of months, we can see that there is no sign of any mold buildup. Okay, so moving on to hand hygiene with ozonated water. So as I mentioned as well earlier on in the presentation, ozonated water is not new to the world. It has been around since the early 1800s for the purification of water. So it certainly isn't new to the world, but it is emerging within the healthcare environment. So it has been known for decades how important hand hygiene is to prevent the spread of bacteria and disease, and now even more so. I'm sure everybody sitting in on this presentation is very, very well aware of the COVID-19 pandemic and the importance of hand hygiene. So what we know is that hospitals and healthcare facilities are designed with hand hygiene sinks placed throughout the hospitals, specifically there to help control the outbreaks of any infections or hospital-acquired infections or bacteria infections. Unfortunately, in some cases, hand hygiene sinks have actually contributed to these specific outbreaks. What's quite ironic about that, sadly ironic, is that the hand hygiene sinks specifically designed for the purpose of controlling outbreaks have actually been the source of outbreaks in certain cases. So in addition to the lessons learned with respect to sink design, infection control experts have also studied hand washing and have proven the importance and how important it is to use proper techniques. So we've heard this many, many times now, the 20-second rule, the 6-step method. It's pretty much ingrained specifically after COVID-19. What we also know is that by not following proper hand washing techniques, the results can be very, very poor. What we can appreciate and what we do know is that hospital staff are on board with proper hand washing techniques and the frequency thereof. But that really only forms part of the puzzle. That really is only part of the equation. Hospitals and healthcare systems are not designed for healthcare workers alone. They are designed for people and for visitors and for anyone that comes into the healthcare environment. So patients and people themselves play a vital role in their own safety against infection in the hospital. So a study was done in patients in hospitals using RFID tags. And what the study showed is that the people in this particular case only washed their hands about 70% of the time. So of those that did wash their hands, only about 30% of them used soap and water, and only lathered for on average about 10 seconds. So we have a look at the previous slide, the 6-step method. the importance of lathering for 20 seconds. This particular study showed that 70% washed their hands and only 30% used soap for 10 seconds. So not great if we have a look at the proper cleaning methodologies and techniques out there. And sadly, this really is the onset and where these outbreaks start. So what we also know is that any bacteria left on people's hands can continue to grow and double in less than 20 minutes. So I'd like to share the story behind the use of ozonated water for hand hygiene. So between December 2004 and March 2006, a prominent hospital in Toronto, Canada, experienced a deadly contagious pseudomonas outbreak that led to 17 deaths and 36 patients developing serious illness while under the hospital's care. In addition to this prominent case, there was another hospital that experienced a similar outbreak. And here we saw 66 patients infected or colonized by a pesky drug-resistant bacteria called Klebsiella oxytoca. So that was from the fall of 2006 to the spring of 2011. So this really was a highly publicized instance where an outbreak was traced back to a sink. And again, I refer to the sad irony of the hand hygiene sink being built for the purpose of controlling outbreaks. This is real life examples of where it was actually the cause of a very, very deadly outbreak. And that really is where we decided to take action. So we asked some very, very critical questions. What if you could wash your hands with water that was twice as powerful as bleach? You could clearly eliminate the issue of bacteria buildup on people's hands very, very effectively. But in addition to that, we asked the question, what if you could eliminate the sink as a source of infection for bacteria? So it really makes sense to use ozonated water for hand washing. Ozonated water improves the effectiveness of hand hygiene regardless of the technique being used. So it helps kill bacteria whether soap is used or not. So I would like to just pause on that point. We are using the example on the next slide purely as an illustration of the effectiveness of ozonated water in killing bacteria, but we very much adhere and recommend the guidelines put out there by the CDC in terms of using soap and water. But specifically for the purposes of this presentation, we would like to put the effectiveness of ozonated water. So a university study performed hand wash studies on untrained users. And for the large percentage of people that only used water to wash their hands, we can see that the improvements are there. So only using water, we're seeing an efficacy of 33% of bacteria being removed. If we have a look towards the right-hand side of the slide, by using ozonated water alone, we are seeing an effectiveness of just over 80%. So it really is very, very significant and very, very effective using ozonated water to help combat bacteria, not only on people's hands, but also on eliminating any bacteria buildup and biofilm within the waste trap. Many people ask the question, well, how can soap and ozonated water be less effective than using ozonated water only? From what we understand is that the soap does form a barrier or a film between the ozonated water and the bacteria, and this to some degree reduces the effectiveness of the ozonated water if it was used alone. But a very, very clear illustration in terms of the effectiveness of ozonated water. So I'd like to look at the benefits of ozonated water in reducing biofilms in hospital wastes and traps. So I mentioned the benefits of hand washing, with ozonated water, which is very, very clear. We're seeing effectiveness of over 80%, and again, a very, very first line of defense for those people who do not follow effective hand wash techniques using soap and water. But in addition to the benefits of hand washing, the larger benefit of ozonated water is that it will keep the sink waste free of bacteria and biofilm. And again, if we reflect back to the cases where the sink was the origin or the source of the outbreaks, it is clearly a very, very clear benefit that ozonated water can help eliminate that by clearing the waste traps of bacteria and biofilm. So what we do know is that water can splash from the sink drains, which are the perfect breeding ground for bacteria and biofilm. They are constantly fed with a rich diet of biological material. And what we also know is that once a sink is contaminated, the biofilm can grow as much as 1 inch a day throughout the plumbing and can contaminate other sinks throughout the facility. Very similar to what we would have seen with the outbreaks that we spoke about earlier. So once contaminated, sinks can splash this bacteria up to 3 feet from the sink into the air, onto users, and onto nearby surfaces. And sadly, that is where the outbreak really kicks off. So what I would like to share with you is a study that was presented at the SHEAR National Conference in April 2018. So what they spoke about at the conference really focused on hand hygiene sinks and how contaminated sinks and drains are rapidly emerging as a cause of healthcare-associated infections. And in particular, this was being seen in intensive care units. So drain contamination is particularly difficult to eradicate due to the propensity for the biofilm formation in the piping, as I had mentioned. It can grow as much as 1 inch per day. So testing was done at the Cleveland VA Hospital to study the effectiveness of ozonated water in eradicating bacteria, as well as a new concerning superbug called Candida auris. Some of you may have heard about Candida auris. If you haven't, I would encourage you to Google it if you have some time. But really, prior to COVID-19, Candida auris was one of the newer, if you want to call it, superbugs, in addition to C. diff and MRSA, that hospitals were fighting and continue to still fight during the COVID-19 pandemic. So Candida auris, very much like C. diff and MRSA, can spread like wildfire into a patient's room, and it really spreads onto surfaces, including walls, floor tiles, ceiling windows, and it really is a deadly bacteria that spreads tremendously quickly. So what came out of the study, having a look at ozonated water, was that there was a total elimination at the strainer after 2 days of use of ozonated water, and a total elimination of the entire trap within 9 days of use. So if I can pause on that point, if we think about the propensity for the bacteria and biofilm to grow throughout the sink, to splash onto surfaces, and to grow within the system, we're seeing a very, very quick elimination of both the strainer and the trap of 2 days and 9 days, respectively, after use of ozone technology or ozonated water. So what was concluded from the study and from the SHEAR conference is that ozonated technology has the potential to significantly reduce the number of sink-associated infections in hospitals. So really, in summary, and just to reflect back on some of the alarming statistics that we had a look at throughout North America, the annual costs of HAIs are estimated at around $136 billion per year. It's a significant amount of money. It accounts for more deaths than car accidents, breast cancer, and HIV/AIDS combined. And I would like to pause on that point, a lot of these very deadly causes of death and very sad causes of death get a lot of spotlight, a lot of media attention, a lot of talk. But I don't know how many people are talking about hospital-acquired infections and the fact that they rank within the top 5 causes of death in North America. And really, if we think about the domino effects that HAIs have on the healthcare system, on the livelihood of people, and in terms of long-term disability and increased resistance of the microorganisms, it really is a very, very topical issue that the healthcare system and really society as a whole has to deal with. So if we have a look, and I've mentioned throughout the presentation that these are not new technologies, they have been around for many, many years. It is generally believed in healthcare that it takes 17 years from innovation to implementation of new technology. The simple fact, again, if we have a look at the stats, if we have a look at what was discussed throughout the presentation, and even more so now during COVID-19 and the impact that that has on the healthcare system and on people's lives and the overcrowding issue, it really means that the time for action is now. HAIs have not gone away since the COVID-19 pandemic. If anything, they have been more of a burden for healthcare systems to try and eradicate as they grapple with the current pandemic. So really, it's all about action, and the time for implementation of these not new but emerging technologies is now. So what the experts feel after the various studies that have been conducted, if we have a look at UV disinfection, if we have a look at copper touch surfaces on the high traffic areas, if we have a look at ozonated water, specifically with the use in hand hygiene sinks, these technologies, according to the experts, can reduce the risk of an HAI by as much as 80% and drastically minimize the number of HAI fatalities. So from traditional cleaning methodologies to the implementation of these emerging technologies, we can see the reduction of as much as 80%, which is a significant number, taking into account those domino effects that we have addressed. So in conclusion, the research into developing this hand hygiene sink solution incorporating ozone technology took into account a number of factors. It had a look at the sink design, what really took into account poorly designed hand hygiene sinks and how they contributed to the outbreak of infection. So the design really has a look at the elimination of standing water and the elimination of splashing from the drain onto nearby surfaces. The research also had a look at ozone and its effectiveness in killing germs and bacteria, 5 times as effective as bleach, together with all of its environmentally friendly properties. It also took into account a true laminar flow. So the flow that comes from the sink is a true laminar flow, which is designed to reduce splashing on the hand, but also importantly, splashing from the sink onto the user and onto other nearby surfaces. Another aspect that the research into the product took into account was the 20-second lather time, the recommendations for the effective hand washing techniques in terms of eliminating bacteria on people's hands. So all of these various factors, from sink design to eliminating splashing to the effectiveness of ozone technology, all designed to eliminate the sink as a source of bacteria outbreaks. Just on the point of the 20-second laminar, that is not a locked, it's not a locked out feature. It can be overridden purely by people putting their hands under the sensor, and the ozone technology will dispense immediately. But it really is just a safety mechanism for correct timing of hand washing techniques. So what has also been taken into account for applications where hand hygiene sink cannot be replaced, a retrofit solution is available. And this slide gives a illustration of a trough sink, and that trough sink is made of a Marinette material, which is a composite of quartz, stone, and marble. And you can see there is the integration of an OzoFlow solution installed, and that includes a touchless faucet and ozone generator underneath the sink. So fundamentally, it performs the same feature as the hand hygiene sink with the ozone incorporated. However, this can be retrofitted to existing hand hygiene sinks. Faucets really come in three styles: from an angle deck mounted, wall mounted, goose deck mounted, and each faucet comes with its own ozone technology device, and they're all made from solid type 316 stainless steel, are extremely durable, and are hands-free or touchless operation. So I would like to thank everybody for sitting in on the CEU presentation on engineered infection prevention. If you have not already put any questions out there to Corey Macy, I would like to now open up the forum. If there are any questions on hospital-acquired infections, on any of the technologies that have been introduced, be it ultraviolet disinfection, copper touch surfaces, or ozone technology, I would very much like to hear any questions or comments. But thank you very much.
Yeah, thanks, Allan. I did get a couple questions to me in chat. The first one is ozonated water potable?
We don't recommend drinking it. It's meant for hand washing only, but incidental consumption. Some people do drink it for health reasons, but literature is kind of inconclusive what the results of that are. There's good bacteria in your stomach. Theoretically, you could be killing some good bacteria, but it doesn't pose a health risk.
Okay. Next is ozonated water caustic to the drain system?
No, it's the ozonated water and the other oxidants that we're producing at most around 2 ppm. So it's not at a level where it's going to start eroding materials. It's to compare it in oxidation levels, it's similar to a well-maintained swimming pool.
Okay. That's what I got. Anyone else have any questions? Okay. Okay. Well, thanks again, Allan, and thank you, Corey. Awesome presentation, and thank you, everyone, for joining us today. It was an ASPE CEU class, so at the conclusion of this class later today, I'll send you an ASPE CEU certificate. And please join us for our next class on June 16th, covering behavioral health care practices. So thanks again, everybody, and thank you, Allan. Thank you, Corey. Hope you all have a good day.
Awesome, Jim. Thank you very much. And we will be sending a summary of the presentation as well, if you would like to share that with the attendees, but that will give a nice overview of what we had addressed in the presentation, as well as useful links that they can click on.
Great. Oh, and also, everybody, if you want a personal class, or for you or your staff, just reach out to me or any associate at Disney-McLane and Associates, so we can get that set up for you as well. So thanks again, everyone, and hope you join us next time.
Awesome, Jim. Thank you very much.
Thank you. Bye-bye.